Hello. So today what we like to do is we like to see how we can count in various different cases. First, I want you to try to do this do now question. List all possible numbers you can create using these three given numbers, but you have to use once per time. Meaning you cannot do 111 or 112 things of that sort. You have to use one number per. Okay. All right. So I'm gonna give you a little bit of time, and we'll talk about it together. Great. So I'm sure you had a great time thinking about each cases. Yes, first case is writing down the numbers as it is. So 3, 2, and 1. Second case would have been keeping 3 in the front, but I can switch these two, isn't it? 1, 2. All right, then given the 3 is in the front, we can create any other numbers besides these two. So what if I were to say 2 is the front? Then I can say 2, 1, 3, and 2, 3, 1. I can switch these two numbers. And another case is what if I have 1 in the front, 1, 2, 3, and 1, 3, 2. So total we have 6 cases. Now, but the thing is, what we want to do today is that instead of just listing all possible cases, which is great, but we want to see if there's any shorter way of doing it, or more effective way of counting it. So in fact, what we could have done was this. In this case, the fact that we have 3 numbers, and we are trying to create a 3-digit number, how many possibilities do we have in the first case? Yes, we have 3 numbers. Any one of them is possible. How about in the second case? That's right. Since we used one of the 3 numbers, so we now only have 2 choices. And then the last case is there's only one such case. So we have 3 cases possible here, and 2 cases and 1 case. If you imagine a factor tree, or since our connecting word is and, then in probability or counting principle, the word and implies the multiplication. So we have to multiply these 3 cases, or these 3 things, we end up getting 6. So either using thinking about number of choices, or actually listing them, one way or the other, we'll get the same answer. Alright. Then, how about this one? How many ways can you arrange 5 cards shown below? So we have ace, 2, and the joker, 4, and 5. So we have 5 cards here. Alright, I'm going to give you a little bit of time for you to think about it also. Great, yes. I'm sure if you, in order for you to actually, list or arrange each card, it may not be that easy, you see? I can move this one and then this way, or bring this one over this way, I mean, there are many different ways of doing it. Now, but is there a easier way for us to, count how many possible ways there are? Yes, in fact, what I'm going to do is this. I'm gonna put the 5 blanks because we have 5 cards that which we have to arrange. And how many possibilities do we have in the very first spot? That's right, we can place any one of them, so we have 5 choices. How about on the second spot? That's right, we used 1 already, so we only have 4 choices. Likewise, how about on the third spot? Yeah, 3 choices. And here we used the 3 cards already, whatever that 3 might have been. So therefore, we only have 2 choices. And this one is fixed, which is only 1 choice. So if you're to multiply all of them out, we get to realize that this is, yes, 120. Now, but since these, as you can see from this question or even to now, there are many times we end up writing down the numbers starting from a particular number and goes all the way down to 1 in counting principles. So in fact, there's another way for us to describe this one. It's called 5 factorial. This, exclamation mark. This basically means just starting from this number, I'm going to count all the integers down to 1. So 5 factorial is another way for us to describe this one. That's right. That means, in this case, we could write this one as 3 factorial. That's equal to 6. Now, if you have calculator, the factorials can be found from here. Put down 5 first, and go to math, and you see the probability. Go all the way down there, and use number 4. then that's 5 factorial. We're going to multiply 5 all the way down to 1. If you press enter, then as you can see, we have 120 shown just like how we calculated earlier. Alright, great. How about the next question? Isabel is trying to create 3-digit numbers. Okay, not 5-digit, 3-digit numbers using the values from the set. Once again, it's five values. How many numbers can she create if numbers cannot repeat within the three-digit number? Alright, so I want you to think about that 1 second. Alright, I'm sure 1 second is over. So in this case, I'm gonna put 3 blanks here instead of 5 because we're trying to create 3-digit number. How many possible values are possible? How many numbers are possible in the very first place? Yes, any one of them is possible. So we have 5. How about on the second spot? Similar to the previous question, we could have 4, and here we could have 3. Now, if you have to multiply these 3 things, then we'll end up getting 60. But okay, great, we got 60, but we cannot actually describe this one as 5 factorial, isn't it? Because 5 factorial would have been great, except that we don't have 2 and 1. So in fact, what we could have done was we could divide by 2 factorial, because 2 and below is not connected. Now, in fact, this is also a very popular expression, so what we have done was we use something called permutation. You see, the meaning of the word permutation is arrangement. You see, so basically what we can do is this. Basically, we can express something like 5p. Now, this number is quite interesting because this number is not 2, but rather 3. This simply means that out of 5 things, I would like to arrange 3 things, just like how we have done here. Out of 5 things, we like to arrange 3 things. Since arrangement, the orders are important, we kept the orders, and that's basically how we can describe it. And that basically means this one. Now then, what is the formula? How do you get this? By definition of NPR, that means we're going to arrange R number of things out of N number of things. That's equal to N factorial divided by N minus R factorial. You see, that means even in this case, 5 factorial divided by 5 minus 3 factorial. Then as you can see, 5 minus 3 becomes 2. So that's how we could have described it. Now, just for your information, in the previous case, in this case we are looking at 5 things, and we like to arrange all of them. So yes, we could have used 5 factorial, or this can be written as 5p5. You see, out of 5 things, we're going to arrange all 5 things. Alright. Then how about the next case? Claire is trying to create 3-digit numbers similar to before, but using the values from set B. How many numbers can she create if she uses a number cannot be repeated within the 3-digit number? Alright, okay. So we're going to have 3-digit once again. How many numbers are possible? 5? No, actually no, it's not 5 numbers that are possible in the first spot, but rather 4. Can you think of why? Yeah, in fact, 0 is not possible on the first spot, because if you have 0, 1, 2, then it will no longer be 3-digit number, but it will be rather 2-digit number, 12. You see? So 0 cannot be in the first, so therefore we only have 4 choices. How about the second? Is there any restriction on the second one? No, there isn't. So we can write down anything that there is. So out of 5 numbers, we use the one number. That's why we have 4 choices here. We have different reasoning, but same number of possibilities. And then third one, since we use 2 numbers, we only have 3 choices. So this becomes our answer. So once you multiply them, we get 48. Becomes our answer. Alright, how about this one? How many ways can you arrange the given words? You see the word arrange? It implies the permutation, but let's think about this one for a second. How many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, you know what? Our answer would have been 11 factorial. But wait a minute. That's right, we have M here and m here. It repeated. So whether I put m here and then switching this m back and forth, it's going to be exactly the same thing. In other words, what if I have take this m over here, this m over here? It looks like a different arrangement, but they're exactly the same thing. So what I have to do is I have to divide by 2 factorial, because the way that I can arrange these two things, I overcounted by the factor. Oh, wait a minute, not only that, a has repeated also. A repeated here, and a repeated here. So therefore, I have to divide by 2 factorial for that too, because I overcounted them. Now, how about t? I have one t here, and one t here. Ooh, so I have to divide by another 2 factorial. H? No. E? No. Alright, that's it. So then our answer is 11 factorial divided by 2 factorial by 2 factorial by 2 factorial, because each one of them represents overcounts by having the same thing repeating over and over again. So therefore, our answer will be, I'm going to use the calculator here, 11 factorial divided by 2 factorial. But what is 2 factorial? That's right, it is simply equal to 2. And then another 2 factorial, that's equal to 2, because 2 times 1 is equal to 2. And another 2. Then that becomes our answer. Alright, then let's look at the next one. There are 2 identical red chairs and 3 identical blue chairs. How many ways can you line them up? Alright, so we have red, red, and blue, blue, blue. This question is somewhat similar to the earlier one, isn't it? We just have to calculate how many things there are and then divide by the repeating things, factorial. So in fact, this one would have been, since we have 5 things, 5 factorial. But I have to divide by 2 factorial. And then I have 3 things repeating, so I have to divide by 3 factorial. Now, if I were to calculate this one using a calculator, then I'll be getting 10. Alright, so we can finish right here, but let's try to think about it then. In number of arrangement, if you had to put that into formula, you would have been something like this then. Number of arrangement is n factorial divided by first one repeating factorial times second one repeating factorial, and so forth and so on. If I have 3 things, then it would be our third thing repeating factorial, and so forth and so on. So we can solve this question using a factoring concept. Arrangement concept. But wait a minute. This is actually quite interesting because we can view this one in another way also. You see, we have 5 locations. In fact, out of 5 locations, how many ways can I pick 2 locations? So that it will be the place for the red chair. That's another way of looking at it. And the rest of them can be place for blue chairs. So I can pick these 2. Or I can pick this one and this one. Doesn't really matter. However I pick. In other words, number of ways picking 2 places out of 5. That's in fact called combination. So we write it as 5C2, meaning out of 5 things, we're picking 2 places. Order really doesn't matter, however we choose. And that, in that case, we use the 5 factorial. And then, in fact, this becomes 5 factorial divided by 5 minus 2 factorial. Just like what we are doing with the permutation, but we have to divide by this one one more time, 2 factorial. Which is exactly the same thing as this. Hence, we end up getting 10. If you have to use the calculator, out of 5 things, 5 and math, numbers, and you see number 3, NCR. So 5 NCR and then 2 then we'll be getting 10, just like we talked about it just earlier. All right. Now, then this is the formula for the arrangement, and this is another way for us to look at it from combination point of view. How about this one? There are 9 students in a club. How many ways can you select 3 students to represent a club? You see, in this case, I'm selecting 3 out of 9, but does the order matter? Because we're just trying to see who can represent it. So then in our case, it would be 9C3. That's all we have to do. So using your calculator, just one more time, what we could have done was 9 math, go all the way till the end, number 3 and 3. Let's see. So 84. There are 84 ways to pick 3 students to represent the club. All right. How about the next question? There are 5 students and then 3 teachers. How many ways can we select a committee of 2 students and a teacher? So let's look at 2 students. That means 2 students out of 5 students. So we have 5C2. And means multiplication. So we're going to multiply that by a teacher out of what? 3 teachers. So 3C1. You see 5C2, we calculated that earlier. As you can see, that was equal to 2. I mean, that was equal to 10, rather. And 3C1, if you were to use the calculator, that would be equal to 3. So our answer becomes 30 ways. There are 30 ways to select the committee, because in the committee order doesn't matter who comes selected first or second. So in that case, we can use 5C2 for choosing 2 students, and then 3C1 for choosing one teacher. All right. And that's about it, and I'll see you later. Bye-bye.